Our next presentation is from Tripp Shenton. He's a professor, Department of Civil and Environmental Engineering at the University of Delaware. He's going to give a summary of some maintenance practices with steel bridges.
Good morning. As Ben said, I'm going to talk a little bit about some research, or actually some observations coming out of some other research projects having to do with maintenance practices. So really kind of full disclosure, this is not a presentation on a formal research project that looked at maintenance practices. This is really just, as I said, some observations that came out of a couple different projects that we've had over the years. Those projects, first of all, going back several years ago, we did a small project for the Northeast Partnership looking at the performance of small movement joints. And as part of that, we surveyed the Northeast, gathered maintenance manuals, reviewed those, et cetera. That led into a larger NCHRP project that we were awarded, and that was 12100, and that was to develop guidelines for maintaining and repairing small movement expansion joints. And so in that one, we also did a survey. That was a national survey. We collected as many manuals as we could from across the country. Those projects were really focused on looking at joints, and so that was what we were doing with those. The last one is a project that we've been involved with for a number of years under the Long-Term Bridge Performance Program, which is looking at the performance of weathering steel bridges. And so we've been involved in that project for really going on almost 8 years. There were 3 phases to it. That one, we just submitted the draft final report to Federal Highway about several weeks ago. And really the goal of that long-term bridge performance project was to look at the performance of weathering steel bridges and look at the factors that have influenced how they perform. We've already heard cases yesterday and today where weathering steel has performed well, but also cases where it hasn't performed well. The technical advisory from Federal Highway, the 1989 one, gives general guidance on where you should or shouldn't use weathering steel, and Federal Highway would like to update that TA, and this project was really developed to provide data and recommendations to Federal Highway for them to be able to do that. And in fact, our final report has recommendations in there for them to consider for revising that TA. For those who aren't too familiar with long-term bridge performance, the program, it looks at the performance of bridges. They focus mainly on decks over the initial years. This project, as I said, it was looking at unpainted weathering steel, and it uses a cluster kind of approach to look at clusters of bridges from around the country. And so for this project, ultimately, we had 11 clusters from around the country. We were charged with focusing on looking at bridges in regions that have high snowfall and looking at the climate effects, and also regions near the coast. And so we really had 2 different areas where we were looking at. The circles in this slide show you the clusters. The 3 you can see down at the bottom along the coast, those were our coastal clusters, and all of the other ones were our highway clusters. Actually, for this project, first of all, we had to identify all of the weathering steel bridges in the country. The NBI doesn't have a coding item to identify weathering steel, and so that was our first challenge. So we had to basically poll all of the states for their list of weathering steel bridges. We got 48 of the agencies to provide that information, and so once we had those bridge IDs, we were able to extract them out and all of their NBI information. So we created a database of all the weathering steel bridges in the country. It's about almost 10,000 bridges. And then from that, we incorporated other data, climate data such as average snowfall, temperature, humidity, fog, time of wetness, things like that. We also incorporated atmospheric chemical composition, deposition, chloride, sulfate, nitrate information. Also determined the distance to the coast for all of those bridges. So we compiled this large GIS database for all the weathering steel bridges and all of that information. And in fact, that data has been loaded to InfoBridge, And so now if you go into InfoBridge, you can look at all of those weathering steel bridges. In the end, we looked at 192 bridges from these from these 11 clusters, got inspection reports, reviewed those in detail, and looked at the performance of the bridges. We also then went out and did field testing and inspections on 3 or 4 bridges in each of those clusters. So we've been to every one of these and looked at least 3 bridges in each of these areas. For the states that we went to, I got to say thank you for your help, because the states were great in helping us to do this. But all that was to collect this information. We also, and how this ties to maintenance, is we also wanted to look at how maintenance practices affected the performance of the weathering steel. So we gathered maintenance manuals, we reviewed the manuals, and we then incorporated that into the data analysis that we did. Again, the big question was, what factors affect the performance of the unpainted weathering steel? We surveyed and collected data from all of the states, or just about all of them. We also gathered information from some of the other projects. As far as the maintenance goes, besides getting maintenance manuals and reviewing them, it's difficult to get kind of hard quantitative information about practices and how effective they are. That is still a challenge. We ended up getting 34 manuals from states across the country, from agencies. Some of the agencies don't have maintenance manuals. Some of them never responded to our requests. And just so you know, these requests are formally made through LTBP to the state LTBP coordinator. So there's kind of a direct conduit to make requests under LTBP to get information, and that's the route that we went to get that. But in the end, we had 34 manuals to review and look at. When we look at manuals, we'll generally see kind of some general categories almost all the time: joints, bearings, girders, and bridge washing. So we would see those categories. Within them, we would then see perhaps cleaning, repair and maintenance, eliminating, at least that's for joints, bearings, cleaning, repair, girders, about the same. And then some specific categories: bridge washing. Some manuals would talk about corrosion, and then some manuals might have specific information on unpainted weathering steel. So in looking at these, what we're trying to do is, from the manuals, try to get some kind of perspective on the state's practices. Kind of how good or how not so good are they? We can't really, we don't have any other way to really try to assess that, and so we really tried to do that based on the review of the manuals. So what we ended up doing was we developed an objective rating of the manual and a subjective rating. And the objective one was really just a number between 0 and 3, kind of to quantify how many of those different categories we saw in the manual. And then the subjective one was just our review of the manual, what areas it covered, how much depth and detail was provided in these different areas, if they talked about repair strategies, things like that. So what we were working towards was to get some quantitative measure of the manual, because you'll then see how we were going to incorporate this into developing a model for us to predict how the weathering steel bridge would perform, or have performed rather. This is just a table right out of the final report. This is just like a third of the table. Basically, we went through, and for every manual that we gathered, we said, are these different areas covered? The X's show those areas that were covered. And then on the right-hand side, you see our objective rating and our subjective rating. And again, so those are just kind of scores given to the manuals, a quantitative score that kind of assesses, helps us find, what we would think are the really good manuals, and then the others that weren't quite so good. I did pull out the ones that we got from the Northeast. These are just the Northeast ones. Again, if you look kind of over on the right-hand side, all the way down the bottom there is a 3 and a 3. PennDOT, from our perspective, has a really good maintenance manual. A lot of detail. PennDOT in the back there. Very good. Sorry to say, Massachusetts, if we have people from Massachusetts, just kind of the lowest scores. So that led into what I'll show you in just a little bit. But what I did want to pull up, though, was we did ask about bridge washing, and that's a question that we've discussed many times at these meetings, at our monthly meetings and things like that, is who's doing bridge washing, how often, et cetera. So this is nationally, and what you see is from the data we collected, the approximate percentage of bridges washed by agencies. On the left-hand side there, you can see 7 agencies are doing more than half of their bridges. 8 agencies are doing between 10 and 50%, down to 11%, or 11 agencies reported that they weren't washing their bridges at all. And then on the right-hand side, we also were looking for the frequency. And so you can see 11 agencies are washing their bridges, every year. Others, about 5 reported washing every 2 years, and then 5 others less frequently. So it started to give us some information about the frequency. Girder washing, we asked specifically about it, and there you can see the numbers on who's washing their girders. This just brings us to kind of back to this larger project of looking at the performance of weathering steel, and what one of our objectives was to develop a model to help us look at what factors are most influential in determining how the weathering steel performs. And so what we did was we developed a multivariable linear regression model to predict superstructure condition rating. And that's just a basic equation that shows what we're trying to do. A's in the equation are coefficients that we would determine from the regression analysis, and the X's are variables. These variables could be among any of those different variables that we first gathered in the study. So things from the NBI, such as vertical clearance, ADT under the bridge, right lateral clearance, left lateral clearance, et cetera, those kinds of things. The atmospheric chemical concentrations, the chloride, sulfate, nitrate, climate data, as I talked about, temperature, average snowfall, those kind of things. And then the owner practices, which is where the maintenance part of it came in. So initially we had 55 variables to consider. For a number of reasons, we cut that down to 25. And then we set about developing this model. Going into the model, as far as maintenance goes, we used these 6 different variables in the end. Did the agency have a manual? Yes or no? Did each of the 11 maintenance categories exist? Yes or no? The numbers of the categories, and then those 2 ratings that we developed, the objective and the subjective one. Bridge washing, another important factor. We went into the modeling with does the agency wash, percentage of bridges they wash, frequency, did it wash the girders, and did they have separate procedures for unpainted weathering steel. So in the end, again, we had 2 models. We had one for the highway crossings and one for the coastal bridge crossings. And in the end, ultimately, what we came up with, our final model for the highway bridges, it includes 6 variables. The variables that proved to be statistically significant: ADT under the bridge, vertical clearance, does the owner wash their bridge? We also found that the subjective rating of the manual was statistically significant. And so finally, we have the model that we can use by inputting these different factors and see how it affects the performance of the bridge. And that information is what is leading towards being able to provide recommendations on revising that TA, which is probably going to be more specific, well, it will be more specific than what you have today. It was already mentioned, I think, in the previous presentation, their experience of high traffic underneath those bridges that cross I-95. The TA is probably going to be more quantitative. It's going to say if you have ADTs, of, let's say, whatever, 200,000 or higher, you shouldn't use weathering steel. If your vertical clearance, right, is below 20 feet, you shouldn't use weathering steel. It's going to be more specific. just kind of some bottom line comments. Again, I said this wasn't a formal research project about maintenance practices, just kind of a collection of observations from these different studies. We see there's varied practices across the country. The maintenance manuals vary quite a bit across the country, but certainly what this study has shown is that the bridge washing is certainly effective and beneficial at improving the performance of those weathering steel bridges. And so that's it. Thank you. Happy to take any questions if there are any. I'm sorry, say it again?
How many of the states?
Let's see, I'm not sure.
One to that.
I don't know whether I know that off the top of my head. I'm just trying to see if in the table here, bridge washing general, looks like Connecticut, New Hampshire.
We can handle it within our system, but we haven't got it out there yet.
So as I said, the final report for the project was just submitted to Federal Highway. It's got to go through its publication review, its legal review before it actually comes out. Who knows? It's probably going to be another year before it's actually published. And then, but the TA is supposed to be revised based on those recommendations. But that's who knows how long that process will be. So, yeah, yep. I think if I remember, it's about close to 0.8.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.